Yes. For the work algebra chapter, this is the formula that we have seen in our last class, that work done can be calculated if there is an angle between the applied force and the displacement that is given. Here, the original force is working along this direction. F is not labeled here, but this is the original force, which was horizontal. This force was continuously being applied on this object through this entire journey period.
Sir,
Yes.
sir, কালকে কি class হয়েছিল?
Now, class one. So
আচ্ছা।
this force would be applied to this object for this entire journey period, and we could calculate the work done for this force either by taking component of the distance, which is f into d cos theta, or by taking the same displacement while considering the component of the force that works along this parallel line, which is f cos theta into d. Either way, we can go this way, but ultimately we get f d cos theta. This is one of the things that you should know, first of all. Second thing, the new formula that we have is that work done on a fixed amount of gas at constant pressure is given by pressure into delta V. The explanation where this formula actually comes from is not included in your AS syllabus, but just to make you kids convinced that this formula is not essentially incorrect, I can show you a bit of a homogeneity check. Homogeneity check means checking whether this equation agrees physics wise, which can be like this. Let's say that work done on a fixed amount of gas at a constant pressure. So if you have a certain gas contained within a cylinder with a constant pressure of P, and for some reason the delta V is the amount of work done. So if I show you a practical scenario that can elaborate this idea, let's say we have a container that has a shape like this. Okay, I have to move myself. Sorry. All right, let's say this is a certain setup where we have a fixed amount of gas that is trapped within this cylinder. Let's say this is the gas, these are the gas molecules. And I essentially showed it this to be a horizontal cylinder so that we don't have to bother about the weight of the piston. So this enclosed ash colored thing is called the cylinder, and this is what we call the piston. The piston is enclosed on these two surfaces, and there is no friction between these two surfaces for the friction, and between the piston piston outside border and the cylinder inside, there is no friction. So let's say currently the pressure that is working on this side of the piston is atmospheric pressure, and if the piston is maintained at a fixed position, then you also have to understand that the pressure from inside the gas is also exactly that much. So these two are equal. That's why the piston is hold up in a fixed position. So at this point, we have something. Let's say at this point, no, there is no gap between the cylinder and the piston. There is no gap between the cylinder and the piston at this border, but there is a gap inside the cylinder. So it's a frictionless yet movable scenario, but the gas cannot leak out. That's the generalized situation that we're assuming. Kids, if you're asking me questions, I appreciate you cast the question for general chat window so that everybody can understand what I'm talking about. It's easier that way. What is this? Wow. I did not yet know this works this beautifully. Okay, never mind. So let's say just to make sense, if we now apply some heat to this piston, to this cylinder, from here. Let's say we have a Bunsen burner and we apply some heat to this piston. What is going to happen? The heat is going to transfer to the body of the cylinder, and the heat will be transferred to the gas molecules over here. Absorbing this heat energy, some portion of the heat energy, this gas will expand. Since we have allowed the piston to move freely, this gas will expand, so that the pressure experienced by this piston is always 1 atmospheric pressure, because whenever the piston is going to move out, this is going to move out in such a way so that both the ends inside the cylinder and outside the cylinder, the pressure is exactly equal to each other. That's the variable which is going to control the position of the piston. So let's say after a while the piston goes out, and let's say it comes to this new position, which I'm going to show it with a different line. Let's say the piston comes with at this level. So let's say the piston, this is the new position of the piston. Okay, maybe a different color, let's say orange. So let's say the piston comes over here. So let's say, let me just show you the rectangle, that would be better. Let's say this is the new position of the piston. So in this case, the piston is pushed outwards. Now, a couple of things we really need to understand. In the process for the piston to move outwards, what had to be done? Let's assume that the total internal volume of the whole thing when the piston was in the first position, let's say this volume was V1 before heating. Let's say before heating, the volume of the gas was, let's say, V1, and after heating, the volume of the gas was, let's say, V2. If that is the case, V2 is definitely bigger than V1, which means that gas expanded out and occupied some additional volume. Now, here's the thing that you need to understand. For the gas to be expand outwards and occupy this additional volume, which is this much, which is basically the subtraction of V2 minus V1, the piston had to push out atmospheric particles to the right and make its own volume in the same space where earlier there used to be atmospheric particles, which essentially means the gas amount had to push out the atmospheric particles and make their own space. Because the gas did push out the atmospheric particles, we in this case say work was done by the gas on the atmosphere. Work was done by the gas on the atmosphere, because the atmosphere got pushed up, and that pushing happening was made by the expansion of the gas. So the way we write this formula for this scenario, I need to access the scroll bar.
স্যার পিস্টনের উপরে তো ওয়ার্ক হচ্ছে, তাহলে ওইটা মেনশন করব না কেন?
We are assuming the piston is frictionless, and but to move the piston we don't have to spend any energy.
ও আচ্ছা,
If there was a friction that existed in the piston, that's another reason why I have drawn this setup to be a horizontal setup, not a vertical setup. Vertical setup use করলে আবার ওয়েট দিয়ে আবার একটা ওয়ার্ক ডান হিসাব করতে হতো। বুঝছি বলছি?
হ্যাঁ বুঝেছি।
So what I can do, so I need to increase my workspace. Okay, so what you can write in this case, therefore work done by piston, by gas on atmosphere, that can be given by pressure into delta V. In this case, you have to understand that the work was done by the gas on the atmosphere, so work is going out of the system. This is a new set of wording that you have to come across. Work is going out of the system, or in other words, we can say work was done on the atmosphere. So energy was gained by the atmosphere and energy was lost by the gas, or work was done by the gas, so work goes out of the system, and the work is absorbed by the atmosphere. I mean, one of the things that you need to understand, that what do we essentially mean by this? The basic idea for work energy power chapter, one of the basic ideas for work energy power concept is that whenever we do physical work on any object, it gains energy. And whenever any object does some work on its own, typically it can give out that energy. For example, if an object is located at a certain level, let's say if an object is located at a level like this, and if we lift up the object by a certain height, let's say h height, where the mass of the object was m, so the gravity would be mg. In that case, we have to exert at least equal amount of mg force onto the object upwards to balance out this weight and lift up the object by h height and eventually reach to the new position. in this case, external force has to work against the available force of the system. I mean, the default force that is automatically available to for this object is its weight. If we want to move it upwards, we have to add force in the upward direction so that we can overcome the effect of the gravitational force and we can make the object move. In that case, an external force has to do some work on the object. This is what makes the object to gain some GP. We know that formula for GP is mgh. So in this state, the object has a higher GP compared to this level. How much higher GP? The additional GP that the object has is mgh, because we had to do mgh amount of work. So the amount of work that we did gets stored within the object as potential energy. So this is the scenario where we can say work is going into the system. System essentially means this part that I have drawn. I have not shown you the external system. I haven't shown you the hand or a rocket propulsion mechanism or some anything else. The external system which is doing the work is not, or a crane maybe. By some mechanism we are lifting out the object. But in this process of movement, the object is gaining more energy, which means external body is working on the system, or we can say work is going in, or we can say that energy content of the whole system is getting increased. So what I'm trying to transfer is that if work is done on the system, the energy stored in the system increases. If system does work on the outside, then its energy content should be less. Another similar example for this thing can be shown like this. Let's say if we have an object that is on a horizontal plane. For the sake of understanding, let's assume this plane now has friction. Let's say the system now has friction. If we push the object, let's say from this point to this point, by a continuous application of force F, and let's say the reverse force, the frictional force was small f. In that case, let's say if we do this much work to push the object by this much distance, let's say we did, let's say 100 joule of work. So let's say the total, so 100 joule in this case means external force into distance. Let's say this value was 100 joule. The object would not get the entire 100 joule, because to overcome the friction, some amount of work has to be lost. So let's say the total amount of product of frictional force into distance was, let's say 20 joule, which means in the process of doing 100 joule amount of work on the object, we would naturally lose 20 joule of energy from that process. So at the end of the application of force up to this point, this object would have gained some K, and that amount of K again, delta K, would be equals to 80 joule. So in that same process of application of force, we would be losing 20 joule worth of energy due to friction. 80 joule would be transferred to the body, and total amount of energy work done that we had done, it would be 100. Because we have done some lost energy over here, efficiency can be calculated for this setup. But for this case, efficiency is not applicable because I defined this piston to be frictionless. So these are another setup scenario. In this case also we can say work is being done on the system. We are externally doing some work onto the object by pushing it, and because we are doing some work on the object, and the net work that is done on the object was 80 joule, because 20 joule was wasted due to the frictional forces, and that 80 joule of kinetic energy would get stored within the object at the end of the displacement for which we did the force application. That's the basic idea. So in this case also work is being done from the external source, so work is going into the system, or energy of the object is increasing. The other example which I would like to show you is that what are the scenarios where
স্যার
yes,
স্যার এই যে একটা অবজেক্ট দেখালেন না যেটা সারফেসে ছিল, ওটা যদি সারফেসটা ফ্রিকশনলেস হতো, তখন যদি পুশ করতাম তখনও তো ওয়ার্ক ডান হতো না, তাই না?
তখন work done হতো, তখন in that case the entire work done would be transferred to the kk of the object. If this surface is to be frictionless, then this is supposed to be 0. So 100 joule physical work done would be stored as 100 joule kinetic energy into the object. No loss would be there. All of
স্যার
you,
মানে অনেক আস্তে করে ধাক্কা দিতে হতো না তো, আমাদের মানে ওয়ার্ক ডান বলতে গেলে নেগলিজিবল হতো না?
no, here's the deal. আস্তে করে ধাক্কা দিলে অবজেক্টকে অ্যাক্সিলারেশন করা যেত, বাট আস্তে করে ধাক্কা আমি দিব নাকি আমি অনেক জোরে ধাক্কা দিব, and eventually আমার কতটুকু ফোর্স, আমার কতটুকু ডিসপ্লেসমেন্ট দিবে, that is entirely dependent on the scale of the object. For example, if you think for a scenario of a frictionless object, let's say there exists a spaceship in the sky, in the empty space beyond the stars, and you want to move it towards the direction. Now a spaceship could as well be like a couple of 1,000 tons. In that case, to make it move even by a centimeter, you would have to exert some significant amount of force, even if there is no friction. because with a small amount of force, the acceleration will be very small and the velocity gain will be very small, which might not be very practical for to move a spaceship. So it's dependent upon the scale. বুঝতে পারছি?
Yes, sir.
So in this case, if the friction did not exist, I mean, bottom line to your answer is that if the friction did not exist, the entire physical work done would be stored into the object as K. Because I included the example of friction over here, all the physical work done or all the external work done cannot be stored as K into the object because some work would be already wasted to overcome the frictional forces. That's the point that I'm trying to get across. ঠিক আছে? Okay.
স্যার
Yes.
স্যার এয়ার রেজিস্ট্যান্স কি কাজ করবে না এখানে?
ওয়েল আমি এখানে যে ফিকশন বলতে এসেনশিয়ালি একটা ফিকশন বলতে আমি সারফেসের ফিকশন বলছি। টিপিক্যালি যদি এয়ার রেজিস্ট্যান্স নিয়ে কাজ করতে হয় তোমাদের লেভেলে এয়ার রেজিস্ট্যান্স সবসময় একটা ফিক্সড ফোর্স হিসেবে দেবে because air resistance is actually dependent on the velocity of the object, but if we have to consider that variable resistive force, which is a practical scenario, then the complexity of the whole scenario is going to be far too much for your level. So you can assume that this frictional force is the total average frictional force working on the object over this distance d. So that might include the surface friction, that might include the air resistance if that is acceptable. So this is an average frictional force that is a total compilation of all the reversive forces. We can assume that.
ওকে স্যার।
যারা ওয়ালাইকুম আসসালাম। আচ্ছা, সো এটা গেল হচ্ছে আরেকটা জিনিস। নেক্সট থিং যেটা আমাদের আরেকটা যে এক্সাম্পল আমি বলতেছিলাম সেটা হচ্ছে যে if you want to think about a physical mechanism where work can go out of a system, that can be shown to you very similar মানে in a simple example for the case of a elastic spring. Let's say we have a আচ্ছা আমি অ্যাকচুয়ালি এটাকে আর একটু সুন্দর করে রাখতে পারবো. I just take help of this rectangle, black. I got my new printer delivered today. I hope to finish the printing process pretty fast. My old printers got kaput since I started them 2 days back. I have been really messed up for the last couple of days. So let's consider this is a certain scenario of a horizontal plane. Let's say this is a wall, this is a frictionless surface. I have a reason why this is frictionless surface. We can incorporate friction later if you want me to discuss that, no big deal. Let's say over here we have attached a spring. This is the natural position of the spring, and at the end of the spring we have attached a piece of object. Let's say the mass of this object is m. So, and let's say the spring constant of this spring is k. So I'm giving this value of k because every spring. Do you guys know what a spring constant is from O levels? What is k?
Yes.
What is the equation for k?
Sir.
F equals to k. So k equals to f by e, right? So এটার ইউনিট SI ইউনিট হলে হবে হচ্ছে নিউটন পার মিটার, সামনাস সেটা নিউটন পার সেন্টিমিটার হতে পারে যদি এটা সেন্টিমিটারে দেওয়া থাকে, so it can differ. Yes, k is the spring constant, so ধরো এটা হচ্ছে spring constant. And try to understand, let's assume for the time being this surface is frictionless. Consider the scenario for a bit. Let's say this is the equilibrium position for the object. I'm giving a midline scenario over here. If we push the object to the left by a displacement of, let's say, 5 centimeter, I'm giving numbers to make better sense. In the process of pushing this object to the left by 5 centimeter, this spring would undergo a compression of 5 centimeter. This compression would be unnatural for the natural state of the spring, which means because of this compression, we would have to do some physical work in order to move the object backwards. What I mean, even though this surface is frictionless, we cannot move this object to the left 5 centimeter without effort. Without effort means without applying any force. We have to give a significant amount of force to overpower the repulsion of the spring, because whenever we are trying to compress the spring by 5 centimeter, naturally the spring will try to push out the object to the right, because spring would try to come back to its natural shape. That's the whole point of using a spring. So in that case, to make us enable to move the object to the left by 5 centimeter, the spring would produce a force to the right, and we have to overcome that force, or we have to work against that available force within the system to make the object move. By in doing so, we'll be storing some energy in the spring. So when this thing is moved to the left, energy is going into the spring because the spring is deforming from its natural state into a compressed state. So এই পার্টটা বুঝা গেছে কিনা যে when the object is placed over here and the spring is quite squashed up, I am not willing to draw a second view of the spring, so this might be very difficult for us to understand, but let me try to draw the new position of the box with an orange color box. Okay, so whenever we have, so in this scenario the spring would have some stored energy because external work has to be done to make this happen. Now if we let go of this object and move our hand or move our moving thing, this spring will naturally expand and push the object to the right. This oscillation, technically speaking, can go on forever because I defined the setup to be frictionless. But let's not think for the entire journey. Try to consider the scenario. As the spring will expand out, it would naturally automatically push the object from here to here. It will definitely push it further, but let's consider the displacement of the object from this position to this position. I mean, the displacement from 0 to 5 centimeter. When the spring will expand out from a compressed state of this like this to its natural state of this much, where the object will be pushed from here to here, then this is the natural state of the spring, which means at this point the exerted force by the spring would be 0. Here the exerted force by the spring would be k into 5 centimeter. এটা কি বুঝতেছো? স্প্রিং এর ফোর্সের ফর্মুলা হচ্ছে equal to k. So if you do E extension or E compression, the force produced by the spring would be F. So K হচ্ছে তার spring constant বলছিলাম. So K into 5 centimeter is the energy stored when the spring was squashed or compressed by a value of 5 centimeter. Now the spring is trying to extend out. So when the spring actually comes back to its natural shape at this point, when the length of the spring comes over here, at this point the extension has become 0. So the force will also become 0. So the spring is not applying any force over here. But interesting enough, as this object would move from this position to that position, this object would gain some K. Not K, I mean kinetic energy. This object would gain some kinetic energy because by the available force from the spring, this object would be pushed to the right by a distance of 5 centimeter, and this pushing incident would enable the object to gain some kinetic energy. This is essentially correct. So how much kinetic energy should this object get? That answer is exactly by this amount of energy. So if I give some numerical value, let's say this K is, let's say 100 Newton per centimeter. 100 Newton per centimeter. And so the force over here could be, let's say 500 Newton. So whatever that is. I have not shown you how much is the energy. Energy calculation আমাদের পরে চ্যাপ্টার ইলাস্টিসিটি চ্যাপ্টারে ডিটেইলসে আসবে। আমি আপাতত এই ফর্মুলা তোমাদের দেখাতে যাচ্ছি না। ধরে নাও for the sake of understanding যে when we squash the object, let's say the stored energy was, let's say 200 joule. 200 কোথা থেকে আসছে সেটা আমি বলতেছি না, আমি জাস্ট এটা অ্যাজুম করে নিচ্ছি that in the process of squashing the amount of energy stored in the spring was 200 joule, which means when the spring will expand out to its natural length, it would also give out 200 joule of energy, which means the gain of kinetic energy by this object would also be exactly how much? Logically 200 joule.
200.
So this is a scenario. So this is a scenario that incorporates both the example of work going out and work going in. For the squashing process, work was going in, spring was gaining energy because work was done against the available force of the system, which is the resistive force of the spring. That was for the squashing process. When you let go of the spring and the spring is able to expand out, this is when the spring is expanding its own self and pushing an object outwards. As a result, it is losing energy from its own self and transferring that energy to that object. So when the spring would essentially come into this state where the spring has reached to its natural length, then the stored energy in the spring has become 0, and all of the energy has been transferred to the external body, which is the mass that is attached at the end. So the squashing in this example, the squashing means work going in / energy stored. And in this case, the expansion, not expansion means not beyond its original length, expansion to reach original length. The second scenario, that would mean vice versa. What is vice versa?
Same.
Work going out,
Or
energy lost.
Energy lost, or we can say energy released. That would be a better set of wording, but lost is also okay. এই পর্যন্ত বুঝা গেছে কি সবার? এই কনসেপ্টটা বুঝা গেছে?
Yes, sir.
Any question, anyone? Okay, apparently no. So this is the simple formula that we have, P equals to P into V. এটার ফর্মুলাটার জেনারেশন তোমাদেরকে আমি দেখাচ্ছি না। সো এখানে আমি জাস্ট তোমাদেরকে কনভিন্স করার জন্য আমি এই ফর্মুলাটার হোমোজেনিটি চেক দেই। ওয়ার্ক ডান ইন দিস কেস শুড বি W, W ইউনিট হচ্ছে জুল, ঠিক আছে? তার মানে লজিক্যালি স্পিকিং প্রেসার ইনটু ডেল্টা ভি করলে আমাদের জুল আসার কথা। আমি জাস্ট শোয়িং এ হোমোজেনিটি চেক, নট দ্য অ্যাকচুয়াল ডেরিভেশন অফ দিস ফর্মুলা। প্রেসারের ফর্মুলা কি? সরি, প্রেসার ইউনিট কি?
নিউটন পার মিটার স্কয়ার।
প্যাসকেল, বিউটিফুল। আর ডেল্টা ভি হচ্ছে ভলিউম, দ্যাট ইজ মিটার কিউব। সো এসআই ইউনিটগুলো হচ্ছে এই দুইটা। সো প্যাসকেল কে যদি ভাঙি তাহলে আসবে কত? প্যাসকেলকে ভাঙলে আসবে হচ্ছে এটাকে, আচ্ছা আমি এটাকে আমি এখানে লিখতেছি। প্যাসকেল হচ্ছে নিউটন পার মিটার স্কয়ার ইনটু মিটার কিউব। এই দুটাকে মাল্টিপ্লাই করে হবে নিউটন মিটার। Newton multiplied by meter basically gives you joule. So basically this equation is homogeneous on both sides. So I'm telling you that this equation is not incorrect. But how did this equation come into existence? So আমি তোমাদের ডেরিভেশন এখন দেখাচ্ছি না, এটা আমাদের A2 তে আসবে। So the work done on a fixed amount of gas is given by pressure into delta V. So this could mean by either by work done on the gas, or it could also mean work done by the gas. For the example for where I started, when this gas got expanded out and it pushed out the atmospheric particles to occupy a bigger volume, in this case work was done by the gas to push out the atmospheric particles. So in this case we're going to say work is going out of the system, or you can say work is done by the fixed amount of gas, or the energy content of the gas decreased by P into delta V amount. Vice versa, if you now allow the system to cool off, then naturally this volume of the gas is going to become smaller and the pressure would drop, and to maintain the balance of the pressure, the atmosphere is going to push the cylinder inside. In that case the gas would become undergo a lower volume. In that case we can also calculate by P into delta V what is the amount of energy that the gas is gaining from the atmosphere. You might wonder, well, if we are cooling, why should it gain energy? Interesting bit is that by doing P into delta V, we are not talking about the total energy amount of the gas. We are talking about what does this piston position is doing for the gas energy. Try to understand, whenever we will apply the heat to the gas system, essentially these gas molecules would absorb significant amount of heat energy, and because of that energy they are gonna increase the intermolecular space. Molecules would not expand, the gap between the molecules would increase. Do you guys understand this difference? If you ever say that by absorbing heat the gas molecules expanded, would that be correct? Rather than because of absorbing heat the intermolecular space between the molecules got increased. Which one is correct?
Second
Second
one,
one.
sir.
এটা কি বুঝছো সবাই?
Yes.
Sir,
Sir.
হ্যাঁ, ওটা আমি সেন্টেন্স একবার বলতেছি। If we say that by absorbing the heat energy the gas molecules got expanded, or the gas molecules become bigger, would that be correct? Or if we say by absorbing energy the intermolecular space between the gas molecules got increased, would the second statement be more accurate?
Sir, the second statement would be more accurate.
Exactly. You cannot say the gas molecules would expand. This is the wrong set of wording. The students give out quite a lot of time, even though they know this is a wrong thing, because they prefer to use the word expand. You can say the gas expands, but you cannot say the gas molecules expand, because the gas molecules expand would essentially mean that the nitrogen, carbon dioxide, oxygen molecules, they got bigger in size. That is not going to happen. The intermolecular space become bigger because they exert more force onto each other. But that's a different story. Gas law is a totally different story, which is more detailedly explained in our A2 level. So we can get there and eventually go for that. What happens further? So what I'm trying to say that this P into delta V is essentially giving us what is the work. I mean, how does this amount, this calculation is affecting the energy for the gas? If the gas expands in volume, then work from the gaseous system, this piston cylinder gas system, is gonna go out because of the movement of the piston. This means that if volume is increased, then work is going out because work is now being done by the gas on the atmosphere. And if the piston is moving in, then work will be done by the atmosphere onto the gas. So in that scenario, we can say that if the volume decrease happens, then the system would have done, then atmosphere would have done work on the gas. or energy would be gained. So this was for this formula. Then we have this question. Can somebody solve this question? I'll expand out the view. W equals to 100 Newton. Newton likha hoy nai somehow. The weight of this object, rectangular object, is 100 Newton. This object has a dimension of 80 centimeter and 40 centimeter along this case. The question is, how much minimum work needs to be done to topple the object to the right? The solution is not shown here. Only some mathematical calculation is shown. So actually, you shouldn't have access to this calculation, but you do anyway. Can you do logical mathematics to calculate this amount of energy? Minimum amount of work needs to be done to topple the object to the right. Try in your copy. Take a copy and draw up this figure and do some scribbling. I want you kids to really try out this math. I'll give you some time, like 3-4 minutes. So I'm gonna pause the recording because it's gonna be an empty part, and then I'll resume the recording after the 3-4 minutes have passed by. Okay. So how can we solve this math the easier way? So to make it solve, I'm gonna open up Paint to 3D because I'll need to draw some stuffs over there. Okay. So let's try to see the scenario. If I draw a 2D shape, Aisha, তোমার ভিডিও অন করা হয়ে গেছে বাবা, ভিডিওটা অফ করে দাও. You don't need this feed. আচ্ছা, এত মোটা কেন? All right. How? Oh my God. Wow. Okay. So let's assume this is the object which is located onto the ground. So let's say that ground is this one. This is the ground that on which we have the object, and we are trying to topple this object over, toppling to the right. So toppling essentially means we have to roll this object further. Here is the interesting idea that I really want you to understand. To make the object topple, we are going to have to, we will have to, not crop, select. We will have to rotate the object in a direction like this. Actually, are you getting my point? In this case, my entire figure is getting turned up, but we have to push the force from the left, and that way the object should rotate about this corner point of the base. That has to happen. Oh my God,
Yes.
so if I take exactly this much as a possible rectangle, so that I can rotate this. Okay, this is not working out. Let's start from here. So about the diagonal. So I'm trying to choose a section of the figure so that this could be approximately at the center of the chosen part, so that I can rotate this. So if I rotate this, the object needs to be pushed till this happens. This position, essentially what I'm trying to mean, this is the position where the center of gravity of the object is vertically on the right of this point. What I really need you to understand, এখানে আমাদের eraser কোথায়? brushes, eraser, eraser, eraser. So what I really need you to understand that whenever this is achieved, the ground is essentially like this. Ground is like this. ঠিক আছে? Now the object is supported at the corner point, and we need to push the object up to this point so that pencil and a straight line, so that we can have the object located somewhat in this orientation. Somewhat in this orientation. Assume this line is vertical, nearly vertical. So this is a support line that I'm trying to show you. Not essentially perfectly vertical, but bear with me. So what am I trying to show you? So what I'm trying to show you is that let's assume this is the center of gravity of the object, which is located over here. We have to push the object up to this point. Beyond this point, we don't have to push anymore, because when the object is gonna tilt beyond this vertical orientation, its own weight will push it down, right? Think about it. If you have a vertical object that is placed like that, how far do you have to push to make the object rotate till it starts to fall on its own? You have to push the object till the center of gravity is vertically above the corner point about which the object is pivoting. And as you push the object beyond this point, its own weight is going to rotate it further. So all that you have to do is to move the object from the possible vertical orientation. So let me draw the vertical orientation one more time. Let's say the object was in this orientation. So let's say the object was in this orientation. You have to move the object from here to there. এই পার্টটা কি বুঝা যাচ্ছে? This is the amount of work, that minimum amount of work that you have to do to make the object topple over. So let's try and calculate it, how much work that is. So if the dimensions over here was 80 and this one was 40. So if I draw, if I try to find out the, if I try to label the exact midpoint or the center of gravity position, let's say, which is over here. These two rectangles are not essentially of the exact same dimension, but assume that they are of the same dimension. So let's say this is the midpoint of this thing, which would be the cross point of the, which is the intersection point of the two diagonals. How far above should this point be, and how much left or right should this point be? What is the vertical height of this point? এটুক কত হবে?
40.
এটুক হবে হচ্ছে not 40, I think 50. Original figure, oh yeah, 40, my bad. So এটুক হচ্ছে 40 centimeter, right? And how much should this height be? এই হাইটটুকু কত হবে? Try to understand, this is half the diagonal. So calculate the diagonal using the total 140 and divide that by 2. How much should this height be?
20 root 5.
কত?
20 root 5.
No. কত? 42.5.
20 root 5.
No, give me in decimal. Give me in decimal.
44.72.
44.72.
So how did you find this one?
I calculate
স্যার
half
এগুলো
the.
সেন্টিমিটারে, মিটারে চেঞ্জ করতে হবে না?
Well, মিটারে আমরা পরে চেঞ্জ করতে পারবো। আমরা যখন w equals to mgh করব তখন করতে পারবো. You can do the relevant calculation for the working by centimeter, or you can directly change them into meter. Ultimately, you'll get the same value in meter. You're gonna get 0.4472 meter. No problem. এটা পাইস, এই ভ্যালুটা হচ্ছে আমাদের ডায়াগোনালের অর্ধেক। সো এই যে মনে করো যে এখানে যে ডায়াগোনালটা আছে, let me just label this with maybe red. This is the diagonal, right? This is the total diagonal. So এই হাইটটা হচ্ছে ডায়াগোনালের হাফ না? So basically what is happening? This center of gravity position is turning a rotation about this radius line, and it is reaching up to here. এই জিনিসটা হচ্ছে as the object is rotating like this. So this corner is reaching up to this point, this corner is reaching up to this point by rotation. These are not forces. This is the rotation direction.
So, sir, the increase in height is basically the hypotenuse minus the normal height.
Exactly. So in this case, to lift up the object, because the entire idea, I mean, why did we consider for the center of gravity? Because the basic concept of center of gravity of an object is that this is the point inside an object at which we can consider the entire mass of the object to be concentrated. So we can pretty much represent an object as a particle which is located at the center of gravity for that object. So the entire 100 Newton weight that was part of our question, let's say this entire 100 Newton weight was working here, and we pushed this object to the right to give it a height of this much. A2 height gain hoise. So this is the height gain. The value of this height gain should be how much? 4.72 centimeter, right? আচ্ছা 4.72 সেন্টিমিটার, আমার এখানে সেন্টিমিটার লিখছি আমি, জায়গা নাই এখানে, কেমন করে এটা বাড়াইতাম জানি না। So this is the height gain that you have to give the object, and beyond this point the object will naturally fall over because of its own weight. So how much is the minimum work that you have to do? That minimum work can be written as what? Bolo.
Equals MGH.
MGH. In this case mg was 100. In this case h now can be written as 4.72 centimeter, but now I'm convert this into SI unit. So let's say 0.0 আটটা হবে না, 0.0472 মিটার। সো mgh এটা করলে কত আসে?
4.72.
4.72, হ্যাঁ 4.72 joule. This is the amount of minimum work that you have to do to topple over the object. The word minimum is key here, that you have to do physically this much work to rotate this object, and then the weight of the object does the rest. So you don't have to push or you don't have to do anything beyond this vertical orientation. Beyond this vertical orientation, the object will naturally fall over. এই ক্যালকুলেশনের বেসিসটা কি বুঝা গেছে সবার?
জি স্যার।
হ্যাঁ স্যার।
কোশ্চেন থাকলে কোশ্চেন করো, এনিওয়ান? আচ্ছা, let's hope this is correct. So let's choose some other problem. আচ্ছা আমাদের ওয়ার্কশিটে মনে হয় আর কিছু প্রবলেম ছিল, so we don't need this part anymore. Might as well close this one safe. Here we have another formula for the upthrust. Did I teach you the whole idea of upthrust in detail ever?
স্যার আপনি একটা ভিডিও দেখতে বলেছিলেন।
বলেছিলেন যে ক্লাস 9 কে পড়ে আছে।
হ্যাঁ ওটা কি তোমরা দেখছিলা? ওই পজিশনে যে সময় আমি রেফারেন্স দিছিলাম?
জি স্যার।
আচ্ছা যারা দেখছো ওয়েল এন্ড গুড, ইউ নো হোয়াট আপথ্রাস্ট ইজ। যারা দেখো নাই, আমি এই ভিডিও লেকচারের ডেসক্রিপশনে ওই ক্লাস 9 এর ভিডিওটা টাইম স্ট্যাম্পটা আমি অ্যাটাচ করে দেব, দ্যাট লুক আপ আপথ্রাস্ট ফ্রম দিস পয়েন্ট অন দ্য ক্লাস 9 ভিডিও, এন্ড ইফ ইউ হ্যাভ এনি কোশ্চেন ইউ ক্যান সি ইট ফ্রম দেয়ার। সো এটা গেল একটা জিনিস, এন্ড দেন if you go for further down the line, this is the upthrust formula, and then we have a vector quantity. আচ্ছা আচ্ছা এখানে আমরা ওই ভেক্টর মাল্টিপ্লিকেশন এবং স্কেলার মাল্টিপ্লিকেশন বুঝাচ্ছিলাম। This is another question. Take a look at this question. Let me not show you the solution. Hold on, question দেখা যাচ্ছে সবার? Let me read out the question for you. This is a semicircular track. We are releasing an object from the midpoint of the track. So this is the this level is the diameter level. Okay. This object is going to roll down and is rolling down the track, and for 4 different positions A, B, C, and D, we have shown its linear velocity, which linear velocity means this velocity is tangent with the curvature of the track because the object is going around the track. So they are 1 meter per second, 2 meter per second, 3 meter per second, 4 meter per second. Read the question and try to solve this without seeing the solution. Give it a try. Where has the ball lost E by 4 of initial GP? So initial GP is considered as E. Over here, the GP of the object is considered to be E. Question আমাদের এইটুক ডেটাই দেওয়া আছে, অবজেক্টের ম্যাস দেওয়া নাই, এই পুরো জিনিসটার হাইট দেওয়া নাই, কিছু দেওয়া নাই, এইটুক ইনফরমেশনই দেওয়া আছে। এইটুক দিয়ে আমাদেরকে আনসার বাই করতে হবে ABCD এর মধ্যে কোনটা কারেক্ট আনসার হবে। এখানে কারেক্ট আনসার অলরেডি অবশ্য লেবেল করে দেওয়া আছে, সার্কেল around it, but try to figure out why this should be the correct answer and why others would not be. Try. এটা একটা MCQ question, which is a pretty interesting MCQ question.
স্যার ডিজি হতে পারবে, এটা মনে হয় হবেই।
Well, I'm not giving any responses at this point. Think on your own and try to come with some logical explanation through your understanding. You are allowed to be wrong. If you're wrong, I'll correct you, I'll help you understand better, but first think on your own. Take some time. Flying in the night.
স্যার শেষ।
ক্যালকুলেশন করছো?
হ্যাঁ
আচ্ছা, এটা হয়ে গেলে আহ, এটা ট্রাই করো। Let me put that beside this one. ওই কোশ্চেনের জন্য কই ছিল? এখানে ছিল। Okay, let me make both of them available. Okay, এটা হয়ে গেলে এটা ট্রাই করো।
স্যার সেকেন্ড কোশ্চেনের অ্যান্সার কি সি হবে?
না, বি হবে।
স্যার আমি কেন জানি সেকেন্ডটা পেরেছি, ফার্স্টটা পারিনি।
আচ্ছা সমস্যা নাই, দুইটাই দেখাবো, ডোন্ট ওয়ারি। আর একটু সময় দেই তোমাকে ট্রাই করার জন্য। ট্রাই করো, যেটা পারো না সেটা ট্রাই করতে থাকো। ট্রাই টু থিঙ্ক ইন ডিফারেন্ট অ্যাঙ্গেলস এন্ড ক্যালকুলেশন মেকানিজম। ট্রাই, দ্যাটস অল আই এম আস্কিং।
স্যার ফার্স্টটা তো বি হবে না,
ফার্স্ট একটা কারেক্ট আনসার বি হওয়ার কথা। কেন হবে, কেমনে
সেকেন্ডটাও
হবে?
কি বি?
সেকেন্ড আনসার হওয়ার কথা বি, হ্যাঁ, as far as I can remember, but I'll solve them and I'll get to a more concrete conclusion in a while. Can I start solving?
Yes, sir.
Everyone else? আচ্ছা, এই কোশ্চেনটা আমরা একটু খেয়াল করি। আমি এই কোশ্চেনটা সিলেক্ট করে ইয়াতে নিয়ে যাই, কি জানি বলে, এন্টিটি নিয়ে যাই। আচ্ছা, ওই কোশ্চেনটা আমাদের থাকবো, ওই কোশ্চেনটা যেটা আমি একটু পরে সলভ করবো। সো এই কোশ্চেন আমরা ট্রাই করতেছি, খেয়াল করো। Here it says that at which point the object would have lost E by 4 of initial GP. Now, how can we work with this? What this question is specifying that at this level is energy is 0, GP is 0. At this level, sorry, GP is E, my bad, bullshit. At this point, at this level, highest level, the energy stored GP is E. At this level, the GP is 0. So কোথায় 1/4 energy loss হয়েছে? তার মানে রিমেইনিং জিপি কত হবে? We are trying to find out a level where the remaining GP should be how much?
1/4,
No,
3/4,
3/4.
3/4.
এটা কি বুঝতেছো? মানে লস জিপি হইতে হবে হচ্ছে 1/4 and gain GP and remaining GP হইতে হবে 3/4. Now, this information can be calculated out from the information, but this is not very useful for us. The reason it's not useful for us because the question does not work with dimensions, linear dimensions of the height of the object. We don't have that access to the information. All that it gives are the velocities, which means all that we can do is try and calculate out this problem in terms of kinetic energy gain. So let's try to do that. Let's say at the initial point, the object had a kinetic energy of 0. So let's say at starting, the kinetic energy is 0. So beginning, a পয়েন্টের kinetic energy কত হবে?
In terms of m এ বলবো?
In terms of m এ বলতে হবে, exactly, কারণ হচ্ছে in terms of m ছাড়া আমরা
m/2
this should be half m1 square. b তে হবে হচ্ছে half m2 square.
2 square.
Let me delete these parts. আচ্ছা, এগুলো এখানে করা আছে actually. So have a look this one. Sorry. So আচ্ছা, zoom in থাকো. So c তে হচ্ছে half m3 square. So we calculate the kinetic energies in terms of m. And একদম লাস্ট পয়েন্টের মানে টোটাল লাস্ট পয়েন্টের জিপিটা হবে হচ্ছে half m4 square, which is 8m. You have to understand that এই পয়েন্টে আমাদের অবজেক্টে যতটুকু k gain করছে, the amount of k gain that is to this object is the amount of GP to start with, which means initial GP should be equals to final k, which is equals to 8m. Can we understand this much? Because in this process, GP will be converted into k. In terms of m, the final k is calculated to be 8m, which can also tell us the initial GP should also be 8m. GP টা আস্তে আস্তে কমবে, k টা আস্তে আস্তে বাড়বে। So যদি 1/4 k লস হইতে হয়, 1/4 ইনিশিয়াল জিপি লুজ হইতে হয়, তার মানে গেইন অফ k হইতে হবে হচ্ছে 1/4 অফ জিপি। যতটুকু জিপি লুজ হবে ততটুকু k তো গেইন হবে, রাইট?
Yes, sir.
So 8m এর 1/4 k গেইন কোথায় হয়েছে? 8m এর 1/4 করলে কত হয়? 1/4 of 8m মানে হচ্ছে 2m. You are trying to calculate out at which of this position the k of the object was 2m. Have a look. Do you have 2m at any of these options?
জি স্যার, b তে।
পড়ে দেখো, এখন সলিউশনটা পড়ে দেখো। If you have any query, ask me. বুঝা যাচ্ছে? পড়ে দেখো। Take time. Think.
Sir, can I ask a question?
Yeah, sure.
Sir, can I ask why at D, like at that point, the kinetic energy is equal to initial GP?
Because for the curvature of the object, the question specified, which was not written in this question, but I told you in words that this is a semicircular track, which means the lowest point is the bottom of the curve. So if you consider vertical height fall, At the lowest point, the object has fallen down by the highest amount of vertical height, which is essentially the radius of the track. So at that point, your GPU would be 0. So where the location for where GPU is 0, essentially you'll have the highest K. And highest K essentially means this, that is the point where all the GPU initially was converted into K.
Okay, got it, sir.
বুঝা গেছে?
Yes, sir.
মানে লজিক্যালি কনসিস্টেন্ট হয়েছে কিনা এটা বলো।
Sir, yes, sir. Yes.
আচ্ছা, okay, I think this question is done for. Let's try out the other one which was placed at the top of this thing. আচ্ছা, এটা তো PDF. I was trying to show you this one. হয়ে গেল, হয়ে গেল, হয়ে গেল। এই যে। Let's try out this question. I'm gonna rub off this part because we don't need this anymore. Let's try and solve this one. Take a good look and think once again. To make it easier for you, let me ask you, think in terms of mass, exact amount of mass moved, or think in terms of center of gravity. আমি এই যে দুইটা mechanism বললাম, I'm gonna solve this math for you in both of these two mechanism. Either of them can work, whatever suits your brain better, whatever you can remember easily, you can adopt that one, no big deal. But I'm gonna show you both of these mechanism for the calculation process.
Sir,
Yes.
sir, can I ask if the mass of the water becomes half because X and Y are identical?
The amount of mass that water moves is actually half of what is the total mass of the water. All the water doesn't move out because whenever you will open the tap, only half the height of the water is going to move to the right tank, not all of them.
Okay.
Is that what you asked?
Yes, sir.
Yep. Acha, beyond this question, after solving this question, I'm going to give you a bit of break for Maghrib prayer, and as after we resume the class, I'm going to talk about the time rescheduling for the Wednesday class because apparently that is colliding with all the school routines because your school classes have got started. So we're going to have a bit of a discussion about that, and I'll also try to reschedule for the missing classes that I could not do because I was absent.
Sir, what about the test?
The test will happen. All right, let me tell you the solution for this one. What I really want you to think that this container is, this container is identical as per the question says. So whenever we'll turn open this tap, how much water will flow out? Think about this. Should all of this water transfer over here? Should that happen?
For half of the amount. No, for
Half of the amount would happen. So let me try to copy this up and show you the scenario in a different figure. Let's say this is the thing. After we open up the tap, let's say I'm gonna fill this up by half. So let me just draw an ash colored line. Okay, and I would like to make this part become half. So let's say this much water would be missing. Delete, and water would be going to over here, ash color. Okay, no. Okay. So this is what is happening. So this amount of water is remaining unmoved. How much water is actually moving? m/2, right?
G, sir.
Amount of water that is moving is m/2. How much height loss is happening to that water? This water used to be over at this level. Now that water has fallen down to this level. So the height loss of this water can be considered to be h/2 because it has come to the lower half. Now this h/2 can be calculated in two different ways. You can consider from low bottom to bottom. So let's say this much height would be h/2. Or you can take the top reference level. So from here to here is also h/2. This much is also h/2. Or if you're still skeptic about this, you can consider from center of gravity to center of gravity, which means, let's say this is the amount of rectangular piece of water that used to be over here. Let's say the center of gravity for this amount of water was located here, and the center of gravity for this amount of is located over here. So in this case, we are considering the entire water to be a single particle. This is over here. What would be the height difference between these two levels? Well, technically speaking, this should also be h/2, because considering this whole thing as two different parts, this entire uniform cylinder has a height of h. So logically it tells us that because this is half of the water, so this should be 3h/4 above the ground. Do you understand why this is this basic idea about symmetry? বলবা এটা কি বুঝতেছো কেন এটা h/2 হবে বুঝতেছো?
Yes.
Yes, sir.
Yes, sir.
This is basic geometry part. So by all means, the total amount of energy that was lost, or we can write delta Gp, that is about mass of water that has moved m/2. G is G, and amount of height that was lost. So m/2 into G into h/2, which gives you mgh/4. That's the final answer, that how much loss was loss to Gp was happened after this time. So are we clear?
G,
Yes,
sir.
sir.
Yes. So this is 6:59. I'm giving 10 minutes time for the Maghrib prayer. I will resume class at 7:10. Yeah.